Okay, so you can see that exponential and logarithmic functions are closely kin to each other. And just like we had some very important properties for exponents, we're going to carry very, very similar properties over to logarithmic functions. Here are a few of our basic properties, and I'm going to write them in the opposite form so that you can see basically what they're saying and that they make sense. And if you'll just learn the property, just like with exponents, it will cut your time immensely. If I write this in exponential form, that says b, there's my base, to the first power equals b. That is a property of exponents, that anything to the first power is just that thing. This is just the logarithmic way of saying the exact same thing. And for number 2, if I wrote that in exponential form, it would say b to the 0 power equals 1. Anything to the 0 power equals 1. So again, it's not a new rule, it's just a new look to the old rule. Now let's look at the inverse properties. This is in logarithmic form, so I'm going to say my base to the opposite side equals what's sitting up here by the log, b to the x. Now that makes sense because one number always equals itself. So this is my inverse property. If you have a base and then you also have of that same base, it kind of does away with the log base b of b, and all you've got left is x. This is an exponential form, though, so I want to write it in logarithmic form. This is base b, so that would be log base b, of the other side, x, equals the exponent log base b of x. One number always equals itself. So again, these are not really high and hard concept levels. It's just a new look to an old rule, a look involving logarithms. Notice that if you have base b, no matter which form it's in, and then it's got, if it's logarithmic, you've got the exponential statement, and if it's exponential, you got the logarithmic statement, that the exponential and the logarithm are inverse properties. They cancel each other out, in other words. Our goal is to get to where we can just look at these and immediately tell you what the answer is, because they are properties. But to explain it to you, I am going to write it in exponential form. So if I said equals x, this would be 7 to the x power equals 7 to the first power. Notice that x is going to equal 1. Okay? Log base 7 of 7. There's my inverses. Okay, on b, if I were to write it out, it'd be 5 to the x power equals 1. Well, the x power would have to be 0 because anything to the 0 power is 1. Again, that was one of my properties. Log base 4 of 4 to the 5th, say equals x if you want to put it in exponential form. 4 to the x equals 4 to the 5th, so x is 5. Okay, that's one of those inverse properties, just like the 7's up here. Okay, number 6, this is the other inverse property, where I would say log base 6 of whomever, x, equals log base 6 of 9. So quite clearly, x must be 9. That was the other statement of the inverse functions. If you will learn these properties and learn to do it without having to write them in exponential form, these problems will go by much, much quicker.